So let me introduce myself first. So I'm Laura Herlant. I've been working at iRobot for 2 years now. I did first robotics in high school. I was always interested in math and science, but I really got like the robotics bug through FRC. Through FRC, and so at that point, I knew that I wanted to do robotics as a career. And one of the questions that came up is, well, what should I major in for college at that point? And the way that I made that decision is I went and talked to a couple of robotics researchers that were working in a lab at a local university. And I asked them, all right, what should I major in to do what you do? And the response I got was basically pick an engineering. It doesn't really matter which one. If you want to do mechanical engineering, electrical, computer engineering, or any other engineering that's related to the aspect of robotics that you are most interested in, all of those can lead you to working on robots. So at the time, I picked computer engineering because I had been doing some programming for our robots, and I really liked the programming parts. So I studied computer engineering for my undergraduate degree. I went to Georgia Tech. And after that, I knew I wanted to do a PhD because I was interested in doing research. And at the time, there were only 3 universities that had PhD programs in robotics specifically. So I ended up going to Carnegie Mellon for robotics. And now, obviously, I'm working at a robotics company. I work with people from all sorts of different backgrounds, even that are on the same team working on the same problems as me. There are people who come from a background in computer science. There's at least one person who's majors in physics. There's definitely mechanical engineers, electrical engineers working on different aspects of the robot. So I think there's a question about whether you could major in mechanical engineering and still work on robots. The answer is definitely yes. It will determine a little bit more what type of robot or what part of the robot you're working on. So the mechanical engineers I know mostly are drawing up new parts for new robots. They're trying out different models of robots, doing this sort of long-term testing, whereas I do much more of the software side of things. So even though during undergrad and during grad school, I was building robots, now a lot of what I do is programming robots, and I haven't actually built a robot in a long time now. But I definitely still get my hands dirty with debugging when parts go wrong and things like that.
Mm-hmm.
Yes.
Cool.
That's really cool.
Yeah. So I'm on the machine learning team at iRobot, which is in data science. So I work on everything related to algorithms on the robot that make them get smarter, essentially.
That's really cool.
Thanks. Yeah, I think it's really cool. I love working at iRobot mostly because of the people. Actually, it will sound a little cliche, but one of the things that gets me really excited every day going into work, or these days tuning into work, I guess, is getting to interact with other people who are just really excited also about working on robots. It's kind of a dream come true. So that's one of the best parts. And also working on really hard problems, because what I'm doing, it's things that haven't been solved before.
Yeah.
That might not be solved. So that's why I really like it. It aligns very well with the research aspect, because there is, a 50-50 chance that what I'm working on won't work, in which case at a certain point you have to decide that it's not worth going down that route and pick another route to pursue. So
yeah,
it's pretty interesting.
It's awesome.
So let me give a little intro to what iRobot does if you don't know. iRobot, our primary product is the Roomba robot, so the robot vacuum cleaner. But we have worked on a huge variety of robots in the past. And I know you're recording the audio, but can I share some slides here for you to see too?
Yeah, sure.
Yeah, sure.
Okay, cool. Just one sec, I'll get this running. Okay, it might be small, but that's all right. Let me just share here. Oh, I can't, apparently. Host disabled participant screen sharing.
Oh, we did. Hold on, let me fix that.
Okay. What I want to show you is a timeline of the different robots that iRobot has worked on.
Oh.
It certainly didn't start with the Roomba, even though the Roomba is the most well-known at this point. All right, let me try now.
Wow, really? That's interesting.
Yeah, so iRobot started back in 1990. So we've been building robots for 30 years now.
Oh,
Just kind of crazy to
Wow.
say.
very-
Yeah.
That's
So it started back, 1990, with the three co-founders, and started from out of MIT. And we did a lot of work with government contracts, starting with robots that were meant to go out in the field. We had quite some success with some robots for doing like bomb disposal, bomb detection, so that people wouldn't have to risk themselves by going into dangerous situations. Instead, they can drive a robot. The first Roomba was launched in 2002, so that's 12 years after we started working on robots. Continued to work on a variety of robots at that point, both for the military and consumer products. Dabbled in robot toys, which is a very, very hard industry to be in. Did some, even an underwater robot for tracking and capturing an endangered fish. A telepresence robot. Like really, we've done a lot of different robots over the past 30 years. But yeah, here we go. I think I can share now, maybe. Share. No. All right. Anyway, I was going to show you some pictures of the robots, but you can also look them up on our website. Now our most well-known product, like I said, is the Roomba, which is a robot vacuum cleaner. In the old days, in the beginning days, the robot bounced randomly around in order to cover a space, which you would think is very simple motion, but in fact, a lot of engineering went into figuring out how exactly the movement should be such that you would get full coverage of a space, not knowing in advance what the layout of a person's house is, and dealing with the constraints of having a very limited amount of memory on the robot. So that's why the early robots didn't build maps or anything like that, because there just wasn't any space in memory to keep a map, even if you could compute one. So nowadays, of course, we have our robots are mapping the space. So we're using a technique called SLAM, which you may have heard of, simultaneous localization and mapping. So the robot's building its own map as it goes, as well as localizing where the robot is itself in the map at all times. And this is what enables the robot to plan ahead which spaces it wants to cover, what route it's going to take. And so you can get a nice back and forth pattern, which it's been shown that most of our users really appreciate that. They can see exactly where the robot went. And now we integrate also with the phone app, so that if people choose to connect the robot to the internet, they can get reports after the robot has run of exactly the space that it's run in, different statistics that might be helpful. And that's an experience we're moving forward with too in the future.
All right, you should be able to screen share now.
Right, I'll try. Yes. Excellent. Oop. I think you can only, oh gosh, no. Hold on, I pressed the wrong button, it seems. All right, let me try this one more time.
All right.
Here we go. All right, I'm just gonna leave it like this.
All right.
Yeah.
So you can see, this is the timeline showing some of the robots, and there's like the water robot, for example.
Wow.
Yeah, and so right now our main robots are vacuuming robot and mopping robot, but we have many variations of each of them. So here's, for example, one of the vacuuming robots. There's a feature that was just released, I think last year now, for emptying the vacuum cleaner by itself into its base. So this was a big advancement for us, because one of the promises of the Roomba is that when it runs in your house, you don't have to think about vacuuming, basically for months at a time. But when the bin starts to get full and you have to empty it, then it kind of breaks this magical experience where you just don't think about vacuuming, you don't see vacuuming, it just happens sort of by itself. Yeah. So we introduced this this base, which will empty the robot vacuum for you. Therefore, you only have to empty the base, and that can be as often, as rare as once a year or something like that, depending how often you run it and how dirty your house is. So that's really cool. We have a line of mopping robots, which spray water, and they have these disposable pads or reusable pads for mopping hardwood floors. And the point I wanted to make with this was that we have a variety of different robots, which may all seem very similar. And we certainly do, from an engineering perspective, want these to be as modular as possible so that it makes it easy to develop a new robot, and so that all of the engineering work that went into, for example, building one part like the wheel encasement of a certain of our original robots then can be used, the same wheel encasement can be used in other robots. So there is some modular design, but these are actually individual robot lines, and so they do have their own unique set of sensors, their own unique behaviors. So while you might think that there's just one or two robots that iRobot is making, there's actually a huge variety of robots that we're constantly working on and supporting, and we're working on always the next line of robots that hasn't come out yet.
That's really cool.
See if there's anything else from this that we want to talk about. Oh, that's me, by the way, my first robotics team.
Oh, that's cool.
Yeah, back in high school. So I was definitely into robots since I was younger. And then this is at the Personal Robotics Lab at Carnegie Mellon. That's where I did my PhD. So I worked with Herb, this robot butler, on the left here, and then also with Ada, which is this assistive arm. It's meant to be mounted on a wheelchair. So I did a lot of work in human-robot interaction. So making sure that the robot was doing what the human expected it to do. You have to build a lot of mathematical models of what you expect people to do if you're going to be working between a robot and a human in a shared work environment. And a lot of the work that I did there translates into what I'm doing now.
That's cool. So I know that you work in like the software aspect mainly of robotics. So I was wondering like what language is best to learn if you're trying to start in robotics?
So that's a good question. I'll tell you, my experience was I learned, let's see, the first language I learned was probably C, just regular, Objective-C, to use in the microcontrollers actually, in the FRC challenge. And then during my undergraduate, I learned MATLAB, learned some more C. Then in grad school, I used a lot of Python and C++. And right now at iRobot, everything is written in C++ and Python.
Okay.
Well, except we have some robots that are still run on TL, which used to stand for toy language. And that's because we developed our own programming language for some of the early toy robots and then the early Roombas, that made it really, like, it was a tailored language specifically for running these reactive behaviors, which is what makes the Roomba look so intelligent and be able to react so immediately if there's any change in the environment. So in terms of learning a new language, I think you're pretty safe if you do Python and C++ in terms of robotics, because usually code that's running on the robot is going to be running in C++ or something, or maybe C, but probably C++. And a lot of the tooling that's built on top of it is going to be written in Python just because it's easier to iterate in. And certainly if you want to do machine learning, there's a lot of, basically everything in machine learning, there's a Python interface and C++ code running underneath for the optimization part of it. So I think those are probably good languages. Although it's worth pointing out that once you learn one language and learn it well, you can pick up another language pretty easily.
Yeah.
When I started at my PhD, I didn't know any Python at all, but yet I was doing all my work in Python. You kind of pick it up as you go. But it's good to have a good concept on some of the basic algorithms, basic concepts, especially if you want to do like object-oriented programming, things like that. Yeah. That's been my experience, C++ and Python, the ways to go.
That's cool.
Yeah.
Yeah. I know a lot of robots at like iRobot like use your smartphone and stuff for like things. So like how does iRobot keep privacy in mind when they're like programming?
Yeah, that's a good question. So there's a couple things that we do. One is that we keep as much processing as possible on the robot. So a number of our robots have cameras, but a number don't. So the ones that don't obviously have less data that they would be storing to protect. However, it's still creating a floor plan of your house. And so in order to protect that data, not only do we do all of the usual like cloud security protections, but we continue to support the ability to run the robot without connecting it to the internet. So if somebody is very privacy conscious and doesn't want any data essentially coming back from their robot, then they can reserve the right to not connect anything to the internet. They will still be able to put the robot in their house, press the clean button, and it will clean, and it will deliver, you know, an excellent cleaning experience. That being said, they have the option, if you want to connect it to your iRobot account, to an app that's on your phone, you're going to get additional features with that. So you'll be able to visualize the map where the robot ran. You'll be able to get automatic software updates to the robots that are connected to the internet. And that's really a useful feature for us because it means that we can release new features, even on old platforms. Once you've already bought it, we can still allow the customers who've invested, you know, a significant amount of money in their product, you know, and having this robot vacuum cleaner, they can still get the most up-to-date features. So that's a big benefit from connecting it. But I think one of the key things is really that we try to do as much processing on the robot as possible. If there's any data that's going to be removed from the robot, it's very clear to the users. We really are focusing on privacy because we know that having a camera in a private space inside of a person's house, it has the potential for collecting a lot of very sensitive images. And so we just want to be as transparent as possible to all of the customers. If they do want to allow us to process any images or anything like that, it's always an opt-in experience.
Mm-hmm.
Yep.
Yeah.
Yeah. I know it's like, you know, with a grain of salt, because I obviously work there, but I've been very impressed with the attention to detail around privacy and security that iRobot has taken around these platforms. Yeah. Let's see. One of the questions that I wanted to get to was about how the robotics industry has changed over the past 10 years. Mm-hmm. And I just want to say it's changed like amazingly, as you guys are probably aware. Yeah. Just in the last couple of years, we've seen kind of the rise and fall of a number of consumer robotics companies. So just to name a few, and like for toys, we saw Anki produced the Cosmo toy, the little mobile robot, which was impressive in the sense of very like emotive and running actually deep learning models on the robot itself for quite a cheap price point. And I think that's something that actually we're going to see a lot into the future, is a big integration of using machine learning techniques, especially things like deep learning, even on very cheap hardware, because it's really enabling a lot of great robotics applications. We're seeing that in self-driving cars, for example. There's been a lot of focus there. A lot of people are hiring for roboticists, for computer scientists, for software developers related to robotic cars. That's becoming a huge industry. So we'll see how that develops over the next couple of years. But the technology is quite impressive. Let's see what else. Yeah.
So I know that you mentioned about like machine learning and like a lot of the benefits of it. Do you know any like cons, I guess, of machine learning, or is there really any cons of it?
Yeah. So one thing that's sort of systemic about machine learning is that a lot of the approaches, not all of them, but a lot of approaches, especially like things like deep learning, you're essentially fitting a distribution of data. So you end up with this function, which is a little bit hard to describe, which will get you, if I give you some inputs, you'll predict what the outputs are going to be, and then I can use that to do whatever I want. What's tricky about them, though, is that you don't have a lot of expressibility as to what's going on. So if you train this great deep learning model to, let's say, I don't know, detect dogs, because maybe we want to see a dog and do something different if we see a dog. So if you do that, but then some dogs it doesn't detect, or sometimes it says that there's a dog when there's not a dog. Well, how do you really troubleshoot that? It's not like traditional programming where you could go through and you could say like, oh, okay, I wrote a dog detector where I'm looking for dark patches. This is sort of a classical computer vision approach. Like I'm looking for dark patches around the eyes, and I have some threshold about how far away it is from the mouth or something like this. And I need to tweak those parameters because it doesn't detect small dogs or something like that. Instead, it's very much like this huge network with a lot of different weights of just numerical values, and you don't really know which one you should change. So it becomes a lot harder, I guess, to explain what's going on and to troubleshoot it and fix it if there are problems. Then it becomes a lot more of a challenge about picking the right data sets.
Mm-hmm.
And certainly that's something we're seeing right now, is that people in machine learning, it's all about whether you have the right data, you have clean data. You know, that's something that we're working on too, because you want to keep it in a very privacy secure way if you're going to be collecting these big data sets.
Yeah.
But even for robotic, for like autonomous driving, for example, how do you make sure that you have the very unusual circumstances included also in your data? If you just include lots of videos or sensor readings driving on a highway with no interruptions, how do you account for the scenario where there's a cow on the highway? It's a good example.
Yeah.
That's used, right? You're not going to be able to foresee all of the possible occurrences.
Yeah. So like, I guess what's like a method of overcoming those? Because like you said, a cow on the highway, that's kind of unlikely. Like how
do you foresee that in advance?
Yeah, I guess.
Yeah, that's a good question. There's a couple ways to approach it. One is throw more data at it. That's one option that people can do, so that you hope to get all of the edge cases. Another thing you can do is have a prediction of your uncertainty of your model. So not only are you predicting what's going to come out, you know, not only are you predicting what the next state of the highway is going to be, if we continue with that analogy. So you're predicting, okay, there's nothing in front of me, I can go straight. But you're also predicting some confidence on that, where you say, I'm pretty sure you can go straight. And when your confidence is low, you might choose a more conservative thing to do. So you might choose to drive more slowly, or you might choose to alert the driver to get some human feedback, because the model that you're using is not quite sure what's going on. And so you might be able to model that certainty as, hey, I've never seen this experience before. It's really far away from anything I saw in my training. I think I have a guess on what I should do, but I'm not sure. So I really need some more input. So that's another way that you can handle it. And then I guess a third way you could do it is by adding a more like additional safety systems. And so that's one of the things that we do at iRobot, is we have an extra chip that's running on the robot that's just a safety chip, and it's checking a number of low-level signals to make sure that whatever the higher level algorithms are producing in terms of velocities that they're sending to the wheels, that it's actually a safe action. And if it's not a safe action, then it disallows it completely. And so that's another thing you could do, is add extra safety constraints in a more explainable manner. So you have a very explainable algorithm on top, which is checking to see if the outputs are valid according to some very like logical rules that are very explicit. So that's kind of three ways I can think of that you deal with it.
Yeah.
So I know that like machine learning, I'm not 100% sure about this, but there's a concept called like neural networks where like the machine keeps learning, I guess. Is that like a possibility where like, I guess the machine keeps learning, so it's prepared for every single situation eventually?
Yeah, so neural networks are the fundamental building blocks in deep learning. All deep learning, if you've heard this buzzword before, all it is a very deep neural network. So it's a stack of functions. So the one layer in a neural network, you could think of it as like a linear function. So y equals mx plus b, where x is your input, and the slope m plus your bias b are parameters that you learned from your data set. And so then you just stack a number of these up, and they can you can either find those weights ahead of time with a static data set, or you could continually be updating the weights as the robot is running over time. So that's what you're talking about, is this sort of continuous learning, also called lifelong learning, which is the idea that you wouldn't just learn all at once and use your learned algorithm out in the world, but instead you're going to keep learning, you're going to keep updating those weights based on what you see. And that is definitely something that is applicable in robotics. whether you'll learn everything depends on what the experience is the robot sees. If it only lives in one room its whole life, it may never know that outdoors exists, for example.
Yeah.
And so you would learn perhaps a very overfit model that just works inside. And then on that one day that you go outside, the robot fails completely because it's never seen outside. So there is a question about overfitting too much to like the recent data, as opposed to keeping a really long history of everything the robots experience. But yeah, that's a very active field of research, and it's really interesting to see where that's going to be going.
Yeah, for sure.
Yeah, I agree.
Mm-hmm.
So, and like, how do you, I guess, like, how did you learn about machine learning and like deep learning?
Yeah. So part of the, let's see, when did I first? So I took a machine learning class in undergrad. It was one of the optional electives. So I was very interested in this. And then continued to take coursework during my PhD on sort of machine learning and on AI. You'll find there's a huge overlap between machine learning techniques and what's considered artificial intelligence techniques. They're basically a Venn diagram with a lot of stuff in the middle. There's not very much that's just AI that's not machine learning, and there's not very much that's machine learning that's not considered, you would never consider as AI. So any of those classes are helpful. So I learned a lot of this in coursework, but then at iRobot, we started very simple. There was a group of us who were interested in learning more specifically about deep learning because it was quite new at the time. So we watched every Monday, Wednesday, Friday, we got together for lunch and we watched video lectures online on, I think it was a Coursera course, just to get us up to speed a little bit. And then so that gave us the basics of deep learning, for example. So we were all on the same page. And then we started a reading group, which was once a week, where we would read research papers that had come out, because this field is moving very, very quickly. It's a little hard to keep on top of everything because if you read a paper from 3 years ago, it might have already been replaced by a new algorithm this year, which makes the one, nobody then is using the algorithm from 3 years ago because the new one is just so much better. But the result of having such a fast moving field means that you can catch up and be up to speed along with the people who've been in the field for 20 years, like very quickly, because you just have to look at sort of the most recent papers. In order to really understand them, you might need to read back a little bit further. Maybe there are a couple of textbooks, for example, that have been out there now, which cover kind of the basics. And I think that's important to get that before maybe trying to look at some of the state-of-the-art techniques. But for my part, I guess it started with basic classes in machine learning and AI, where I learned some of the fundamental concepts, things like decision trees or Markov decision processes. If you haven't heard of these, don't worry, it's okay. But I started with some of these more basic concepts, and then was able to teach myself the more complicated concepts that came out more recently. All right.
Yeah.
So yeah, I don't know. I've been talking a lot about software because that's my background, but do you have, I assume there's a mix of people who are interested in software and mechanical design.
Yeah. I guess, let's see.
So I did my undergrad degree in computer engineering, which at Georgia Tech at the time.
Oh, nice.
Yeah, so it was exactly the same as the electrical engineering degree, plus an additional discrete math requirement. So I got a lot of circuits, and it's no matter what engineering you come from, or if you do a different major than engineering that's still like math and science focused, you'll be able to draw on those experiences in whatever you're doing. So the fact that I had this really strong electrical engineering background gives me an advantage when I'm working on algorithms for robots, because I understand sort of under the hood what are the constraints going on in terms of like how the memory on the robot works, or how the buses work to communicate between different chips. So even though I'm not using that in my day-to-day, it's still this like background knowledge that's helping out that I draw on from time to time. So I think that's one of the unique things about robotics, is that there is this sort of very cross-disciplinary aspect to it.
Mm.
So I know that you learned computer engineering in your undergrad, and I actually want to go into that, go into computer engineering. So I was wondering, like, whether you learn a lot about like the programming aspects about computers, or just strictly the hardware of a computer.
So I think it probably depends a lot on the university that you go to. I know I remember when I was a junior or a senior going to some of the career fairs, and
Yeah.
you would go and you talk to somebody and they'd be like, okay, what's your major? And I'd say computer engineering. They're like, oh, you mean computer science? I'm like, no, computer engineering. I'm like, what's that? You know? So
Yeah.
it might not be the case anymore, but I think it is a little bit ill-defined. So it will depend on the school that you go to. So check very carefully the coursework that they propose. Okay. For me, we did actually the first year, we did a lot of programming classes. So that's where I learned MATLAB. I learned digital signal processing. So how to analyze not only audio signals, but video signals and radio signals. I took a C programming class where we programmed Game Boy games, actually, and that was really cool because you could see that depending on how you wrote the output to the screen, it could either take 5 seconds to load a single image on the screen, or it could be almost instantaneous, depending on how you're writing. For me, it went all the way from assembly, where you're really sending like very basic commands to the processor, all the way up to, I guess mostly it was like C and MATLAB code. But I think it depends on the program. The other thing that I did, which I'm glad of, is that the program had a lot of flexibility about taking electives, especially in the last year or two. And there I filled all of my electives with computer science classes. Because sometimes the classes that you want won't be in your department. So I was in the ECE department, so electrical and computer engineering. But a lot of classes that I was interested, like the machine learning class, for example, was in the computer science department. So I emailed the professor, and that's the other thing. If you want to take a class that's not on your schedule, there's almost certainly a way to do it. So I emailed the professor and I said, hey, I haven't taken any intro to algorithms classes or all of your prerequisites for your class, but I've done some programming and I'd really like to take your class. Would that be okay? And he called me and asked me a couple very basic programming questions, because of course he wants to make sure I have the skills to succeed in his class.
Yeah.
And then he said, yeah, okay, you could sign up for the class. And so that's how I ended up taking machine learning as an undergrad, even as a computer engineering student and not as a computer science student. So I would encourage you, if you see something that you want to take, reach out to the teachers. For the most part, they're really accommodating and approachable.
Got it.
Yeah. But yeah, well,
yeah. I mean, oh yeah, Prem, what's up?
Oh yeah, so like I don't know. Say you major in like mechanical engineering, right? Is there still a way for you to learn about programming, even though like that's not your?
Totally.
Okay.
Yeah, I mean, I know there's a number of people at iRobot who double majored, which I don't necessarily recommend because that sounds like a ton of work across the two disciplines. But there are some people who've double majored in mechanical engineering and computer science, for example, or who do a minor in computer science. That's like the more formal route, but you can also learn on the side. I think computer science is one of programming in general is a nice one of the nice domains where you can do a lot on your own. There's a lot of good resources online. There's Project Euler, for example, which has a lot of challenging problems that you can work on, and that has solutions too. Sorry, just a second. So you can definitely work on that on your own. I recommend keeping a log of projects that you do. That can be really helpful later, or if you want to either do research at the university, or go to a class, for example, where you don't meet the prerequisites. You can show them like, hey, look, these are what I've done already. You can see that I know some of the basics already. It's useful also if you want to be hired later on. You're trying to boost your resume. Maybe you don't have a major in computer science, but if you want to work in a role that requires a lot of programming, you can point to, say, a website or your GitHub page where you have a number of projects that you've worked on. So I do definitely recommend doing that. If you are fortunate to work at a company where there's a lot of mobility, so iRobot is one of those, then even as a mechanical engineer, if you make it known to your manager that you would like to move into a more software role, that's the type of thing that they would likely be able to offer you some training in that, either that's sponsored by the company, or at least get you to doing some partial project work in the department that you want to work in. So that's something I've definitely done before with people who were not working in, who were not in my group, but who wanted to get into machine learning, where we set up essentially like an intern project, but they're working as a full-time person. They would be able to work on the intern projects and get sort of a taste of it, see if that's what they want to do going forward, and also get some experience. That being said, internships are amazing. If you can get internships, you should. It's very likely, it's a good opportunity first to try out something in the real world, see if it's what you want to do, or if not. If it is something you like, it's a great gateway into either working at that company or getting connections to work at a different company, because robotics is still a relatively small community. So I know a number of people who work at all of the other major robotics companies, and it's really interconnected. You'll run into the same names throughout your career. So it's good to invest in those sort of connections. And remember, it's a small world, so you can make use of them too. Yeah.
Cool. So I think one of the last questions I had was I was wondering what made iRobot unique from other robotic companies, such as like Boston Dynamics. That was just one that comes to mind, but yeah, right. That's the question I had.
Yeah. I think one thing that makes it unique is that it's a very different target audience for our work. So we are a consumer robotics company, so we really are trying to sell to straight to consumers. Yeah, I know. So you have this real connection. That's one of the things that was appealing to me for working at iRobot, is you have a strong connection to your end user. We have people at iRobot who work specifically on this user experience, getting feedback, bugs that are reported from customers. It really closes the loop, and it's very fulfilling to know that the robots that I work on are going out to millions of houses. Like, real people are using them every day. So that's something that I think you would get at iRobot that you might not get at a company that's doing a lot of military contracts or doesn't necessarily have a product yet. So that's one thing. The other thing is the culture at iRobot is fantastic. You can see behind me, like, well, partially. My background says the Builder's Code, and that is something that we've been really supportive of at our company. The idea of tinkering on things, working together to try out, sort of push the edge of the envelope. They have a cool thing at iRobot. They have two cool things that I like. One is there's this idea of a 10% time project. And so that means 10% of the time, so about 4 hours a week, iRobot will pay you to work on your own side project. And they'll even provide funding for it. If, for example, I wanted to use, if I want to use the laser cutter, I can use the laser cutter for my own personal project. If I wanted to use the really well-equipped electronics lab, I can do that. I can use the water jet cutter, and they'll pay for equipment that I need. And these 10% projects, a number of things come out of that. Often it ends up going into other parts of products. So, for example, the rollers that are on the robot currently that we sell, like our Roomba, they have these little flexible rollers on the front. That was somebody in software who decided that they wanted to work on a mechanical project in their 10% time, and now it's on the robot. Oh,
that's cool.
Yeah, so that's a good opportunity. Also, what I was saying before about if you wanted to try out a new field, you absolutely can. So that's one cool thing. The other cool thing they do are what's called STEM days, which is what I'm doing right now. So iRobot also pays us 2 days a year to do events like this. And it's strongly encouraged to take them. And we have a great STEM department at iRobot who organizes these events and makes it really easy for anybody in the company to get involved with outreach if we want to. So this is all part of the culture. It's just everything in iRobot is like this, from like quirky things like at Halloween, we decorate, every group decorates the area that they work in, like crazy decorations. I get really into it. And then we have an open house day where everybody brings their families, and we go around and trick or treat in all of the different spaces. We have a big competition. So that's really like intense and fun. And all of the conference rooms are named after robots, like all of the bathroom signs and everything are little robots and things. It's just everywhere throughout the building. That's just the kind
Great
of
environment.
Yeah, that's what it is. It's a really fun, good environment, but also one that emphasizes a good work-life balance, which is good. We have a lot of families who work at iRobot, like parents or a mix of older people and younger people. You have a good variety of people that are working there, and there's never this pressure that you should be there until 10 p.m. every night or anything like that. It's very much come, work hard, go home, play hard, have your life, and then come back to work. I've never felt the pressure here where you need to be working all the time and that life it should take a back seat. It's never been my experience, which I might have gotten a little bit at some other places. So that's one of the things I really like and appreciate about iRobot. Yeah,
That's good. What's one of the coolest projects you've worked on?
Oh man, they're all so cool. Probably what I'm working on right now, but I can't really talk too much about it. So one of the cool things that we do, and I love working with interns who come in. We have a strong internship program, especially over the summer. And one of the common internship projects is to build a Roomba that can go up and down stairs.
Oh wow, yeah.
Wow.
Yeah, so that's kind of like the fun challenge that we give to interns. In addition to the regular internship work, because they do work on real things that we're using in the products, but then also typically we have an internship project. So all the interns of the summer would get together and they build a project for the summer. And yeah, it's been really fun. I've helped out a little bit with those before. And seeing the designs that come out of it, it's really interesting. So that's probably one of the coolest things.
Yeah.
So do interns at iRobot, like, do they get training like before they actually start like building, or is it all based on like background knowledge you learn in college?
I would say that there is an onboarding process when people join, either as intern or as full-time, frankly, to get them up to speed with a lot of the tools that we already have, that we've built up, over the last 30 years. So there's a fair amount of like code that already exists. So getting people familiar with that, learning more about the robots, what the different sensors are, getting familiar with the CAD software that we use if you're doing mechanical engineering, for example, and the processes. So there is definitely some onboarding that would apply to interns too. There's onboarding, but it's really an ongoing learning process. So I don't think there's so much like a training and then now we're going to work on a problem that you know how to solve. It's very much ongoing, where, I learn a new thing every day. And I think that's what we want to strive for, whether you're an intern or a full-time. And I think that, like I said, I've worked with a number of interns at different levels. I've worked with undergrads, I've worked with grad students, doing their master's, and I've worked with PhD students. And all of them are doing real work. Like it's not busy work. And so that's, I think, been really beneficial. So everyone I've worked with has wanted to stay with iRobot. All the interns I've talked to, and a good number of them actually are now working with us full time. So I think that's just a testament that it's a really good experience. But I recommend, no matter where you do an internship, that you do internships, because it gives you insight as to what it's going to be like really working somewhere. And it gives you a lot of really good experience later when you do want to land your full-time job. Yep.
Yeah, that's cool.
All right. Well, is there any last question before?
I think that's it. So yeah, thank you
That's it.
for.
All right. Awesome. I hope this is helpful. If there's more questions, feel free to shoot me an email.
Okay.
Okay.
All right.
Thank you so much for coming on.
Sure. Thanks for having me.